Hello, good morning to all. Welcome to DBS Site Talks. This is Sujala, HOD, Department of Triple from DBS Institute of Technology, Kavali. Today my topic is present scenario on protection system. So in this session, I want to share a few topics about what is protection, what is the need of the protection, and what are the essential quantities, that is qualities of the protection, and then what are the faults obtained. If the faults will be obtained, how you protect that devices. So these topics you have to share a few ideas about. So in this in the first, in the modern power systems are growing very fast with more generators, transformers, and large networks in the systems. So for system operating, a high degree of reliability is required. So in order to protect the system from damage or abnormal voltages caused by faults, we have to need for the reliable protective devices such as some circuit breakers and relays must be there. So for this, we have to give a small lecture about the power systems. We all know that it is about the generation, transmission, distribution, and utilization. So when you take the generator system, we all know that there is some conventional and non-conventional sources, that is the thermal and nuclear, solar, whatever it may be. We have the input of the generation must be there. Suppose it will be the 11 kV transmission line. So from this generation station, then you go to the transmission. So from the transmission point of view, so why we require the transformer means here whatever the 11 kV must be there, we have to first step up the voltage. So why you have to step up the voltage is because in this transmission line there is losses must be there. So whatever the voltage will be in the input, the same will be goes to the load, then it will the total losses must be there. So then for that purpose, whatever the voltage will be generated from generation section, first you have to step up that voltage. So when you have to step up the voltages, then from the load point of view, there is another transformer that we have to step down the voltage, and then it will be goes to the distributor. That means, so here the generation point of view. So suppose we have to take as A, then it will goes to the B. So here from generation to it will be transmitted, and then it goes to the distribution point of view. In the distribution point of view, what happened? We have to distribute the voltage in terms of the commercial purpose and domestic and non-domestic. That means the industrial point of view, or we have to take as a domestic point of view. We have to distribute this, and then goes to the utilization part. So in this utilization part, if suppose you have to take in the domestic point of view, use the fans, lights, whatever it is, and you have to industrial point of view, there is heating and welding, whatever it may be in the utilization part. That means from generation to transmission and distribution, and then it will be the utilization. So whenever this will be happen, so whatever the power system must be there, so we have to protect this power system, then only it will be the continuity of the supply. So we have to protect this total generation, transmission, and distribution system by the use of the protection. So how you have to protect that means here we use that switchgear units must be there, devices must be there. So under the switchgear devices, there is it's about circuit breakers, relays, CTs, current transformers, PTs, potential transformers. So like that, different devices must be there. We have to protect these total power system by using that devices. So that means the objective of the protection scheme is to keep the power system stable by isolating only the components that be under fault, by leaving as much of the network as possible still in operation. So until you have to be reliability at that means the reliability is required to protect the system from damage and the abnormal condition. That means abnormal support. That means there are severe faults must be. If the transmission line there is a transformer, there is a fault must be occur. Then then total continuity of the supply will be off. So from that point of view, we need the protection. So next, this is the same electrical switchgear, that is the from generation. Then it goes to the step up transformer, and then it will be stepped down, and this transmission to the customers to this sub transmission, primary customer and secondary customer. Here it will goes to the feeders and feeders to the secondary network. So like that, in this you have to observe that the first point here we have to generate electricity generated, whatever the power plants will be there, we have to generate the electricity here. And then whatever the voltage, I already tell that we have to first step up the voltage. From that we have to step up the transmission. Then it is these are the transmission lines to area where the power have to be needed will be the transmission lines. And then the voltage, whatever is 11 kV, you have to step down the voltage, because suppose the step up there is 220 kV, you have to, the input will be the 11 kV, you want the output must be in the kV. Then what is done? Then it will be stepped down to the another station. Then due to this distribute line, we have to the electricity until reaches to the home. So whatever generation, and then it will be the step up, and then transmission line, then it will be the step down, and then we have to use the distribution power line to the electricity until it reaches. So what is the main need of the protective system is to be, that means if any failures may occur in each part, such as insulation failure, over voltage, over current, under frequency, over frequency, whatever it may be, that means fallen as the broken transmission lines, incorrect operation of circuit breakers like short circuits, open circuits, whatever it may be, we have to protect. That means the power system must maintain acceptable operation from, that means 24 hours a day. So whatever it may be, certain limits, that means it's we have generator station. So in each power station there is some ratings must be there. So beyond that ratings must be happened. Then we have to be, there is some fault will be occur. But for that point, for every protective zone, here it will be generator or transformer, whatever it may be, there is the protective zones must be there. So you have to protect to that. So voltage and frequency must stay within the certain limits. Protect the public, and what is the, so you have to improve the reliability, we have to improve the stability, and we have to sensitivity, and whatever the speed, time, whatever you have to be improved. Then you have to minimize the whatever the faults obtained in the system. So protect against overload and minimize damage to equipment. So what is the need of the protection system is, so you have to be short circuit protection device or installed with aims of protection of assessment and ensuring continuity of the supply of the energy. For that point of view, we have the protected system. So system needs means, so there is the no fault free system, safety and personal usable first. That means we already tell that about the overcurrent, over voltage, under frequency, installation failure, whatever will be obtained. So we have to be protect the total system. So then that means what is the use of this term protection means, to indicate that suppose here we use the switchgear is a combination of the electrical disconnector switches, fuses, circuit breakers. So to control and protect and isolate the electrical equipments. So for that, to use that protection means that protect equipment to prevent faults or equipment failures. And it also use that protected system is used for the abnormal conditions. Generally, if suppose there is the normal conditions must be there, abnormal conditions must be. If suppose there is the normal conditions will be obtained. Under the normal conditions, just your isolators or circuit breakers are simply open, and then you have to repair, and that means normal conditions is maintenance and general maintenance and repairs person, we have to normal condition. If suppose when there is the high voltage of faults, high currents of faults will be obtained, then we have to use this protective relays and circuit. So the act as only when the relay will be acted. Relay means to sense, it will be sense one signal to the circuit breaker. Circuit member means it is the open and on and off switches which will be shut down the voltages and it will be protect the total system. So to protect the relays, only after the it will be needs to the abnormal conditions occur. When abnormal conditions means if any faults will be obtained, then that condition will be obtained. General conditions will be normal. That will be only for the maintenance and repair. And protection means it does not prevention. Protection does not. It will be protect the system. It will be. It is not means it will be prevent the system. It will be only the protection. But it means that to minimize the duration of trouble and limiting damage and related problems. Whatever the problems must be there, whatever the faults must be, from that point of view, it will be minimized. It will be prevent. That means minimize the duration of the trouble and the limiting. That means protection does not mean prevention. So you have. So what are the what is about the protection and what are the need of the protection? We already. Next, we see about the what is the essential qualities. This is the very important to protect any system. So that means a protection system is very important for power systems. It provides to operate under abnormal conditions. To prevent failure or limit the effect, every protection must be have some essential qualities must be required. So that essential qualities are, first one is the selectivity, and then it will be the sensitivity. That means, and then it will be the speed, and then simplicity, and then reliability, and then economy. This reliability also there will be dependability and security. That means to perform as design for a system protection, to perform and design of any system protection device include will be the reliability, selectivity, speed, simplicity, and economy. This reliability will be upon the dependability and the security. So every potential system must have these essential qualities must be required. Essential qualities must be required. So here we go that what is the selectivity of the system. Selectivity, and it is called discrimination. Why I am telling this discrimination, I also tell that. So here some detect the point at which fault occurs and disconnect only part without disturbing rest of it. If suppose there is the selectivity and discrimination, I tell what is selective means. So beyond, if suppose the rating of that generator, whatever it may be, some 5 volts, whatever it may be, upon that 5 amps, whatever it may be. So upon that, beyond that, the level will be changed. It means disturb. Then you have to disturb that part only. That you have to select that part, and remaining healthy part will be leave it. That means which fault occur, disconnected only that part without disturbing the rest of the system. So without disturbing the rest of the system. That means the entire power system, generally total power system must be divided into the several protective zones, because for generation there is generator protective zone and transmission protection zone, distribution. So every part must be protective zones must be there. Every part there is a protective zone must be there. So to achieve, that means to achieve the entire part, that means what the protective zones means, there is the primary protection. If it will not rectify, then you go to the backup protection. There are the total over voltage protection. So many protection techniques must be there. So if to selectivity means, so if you select any power system, so we have to select a particular zone of that protective zones. And here distinguish between normal conditions and abnormal conditions. Between normal condition, within the zone or outside the zone. If suppose it will be in the limit of the protected zone, then only it will be operated. If suppose it will be not in that limit, then it does not be operated. That means it will be distinguished normal and abnormal. I already tell what is normal and abnormal condition. If it will be within limit to protect that any equipment, then only it will be act. Otherwise, it does not. So distinguish between the normal and abnormal. So between abnormal condition within the zone or outside zone. So here for internal fault, circuit breaker within the zone will be open. So isolate only that fault, leaving healthy part. That means the main thing is that there is the internal faults and the external faults must be there. But the protective will be held for the internal part of the system. That means if the circuit breaker will be opened in at zone, that means if generator there is a fault occur in a generated point of view, then it will be protected that zone. That means it will be remove that point only, and then the continuity of the supply will be good. So any we have to open and then we have to repair and then restart. Next, protection relay should not operate for fault outside the protection zone. That means external faults it does not operate. So maximum continuity of the supply and minimum system denial. Maximum continuity and minimum system disconnection. That means here, that means the total selective part means we have to select at the particular part whatever the fault occurs. For that part you have to disconnect for that part, and the remaining will not be disturbed. Suppose if you have there is a 5 amps rating must be there, so you have to be exceed that 5 amps, you have to select that part. What is the discrimination means? Discrimination means it will be variation. That means fault is whatever the fault part will be vary and the healthy part will be distributed. That will be called as the discrimination. So the basic here the selective is to select the fault which occurs in the disconnected and distribute the rest. And there is a different protective gauge to select the system, and you have to taken it will be the normal and abnormal condition. And then there is the, if suppose the internal faults of any will be there, we have to go open that fault and isolated only that fault, leaving the remaining part. External parts there is the no outside, it will be not should not operate. And then it is the, but what is the selectivity? It will be the maximum continuity but minimum system. So selectivity means devices must avoid unwarranted false trips. So devices must avoid unwanted fault trips. You have taken the selectivity of the system. This is the one of the quality. Then it will be the sensitivity. So what is the sensitivity of system? So the relay should operate when magnitude of activate quantity exceeds the preset value called the pin. When the relay will be operate, if suppose sensitivity of the relay means if there is some already the rated value will be there, if that exceeds that some preset determine the value, then only the relay will be operated. What is the relay means? It is the sensing device. When it will be operated means when there is the exceed the preset of the value, then only it will be pick up the value. Relay will not be accurate quantity below peak. Below peak means it is a normal condition, so it is not no need to operate. So it will be exceeds, then only it will be on. And it is sensitive to operate when accumulating the quantity just exceeds its peak. Just it will be 5. It will be exceeds some 5.5, 6. Then only it will be operate. The relay will be operate and it will be goes to the signal to the circuit breaker. Then it will be operate. Next, it is the ability of the real system to operate with low value of activating value. It will be able to that means whatever the low values must be, for that purpose the relay system must be operated. And here the main function of the input of the coil is really necessary to cause it operate. That means how much of the rating must be there. We have to go through that rating. At that point of view, it will be taken, and beyond this preset value, the relay will be ordered. At that point, the rating point of view does not, because up to that there is no fault must be occur. Next, smaller the volt amperes input required to cause the relay operation, more sensitive is a relay. That means whenever it will be volt amperes will be required. If the volt amperes input required, to cause the relay operation. If that means the relay will be actuating quantity, it will be like exceeds the setting of the value, then you have to take in the relay will be the operator. That is upon the sensitivity of the relay. Next, speed. If any fault will be occur, then first you have to fast enough to isolate that fault. Otherwise, the total part will be damaged. That means the speed of the operation. Speed means devices must function quickly to reduce equipment damage and fault duration with only very precious intentional time delays. That means it will be operate very quickly to reduce the equipment damage. That means when it will be the fault will be uptime, then you have to very quickly to have to isolate that fault, and then the damage and the fault, whatever the damage will happen, it does not will be happen. So if the speed will be increases, then it does not will be happen. The longer the fault is on the system, the larger is the damage. If we have to take the speed will be it will very slow, then what happen? Automatically the system will be damaged. That means the continuity of the supply will be damaged. So the speed of the will be also must necessary. Also, higher is possibility the system will lose stability. Whatever the speed will be protected, this speed protection system decreases the possibility of development of one fault into other mode. That means whatever the speed must be there, then it will be decreases the possibility of development of the fault. That means if you comes to the slow, if already faults will be uptime, then what happened? It will be damaged. So that is speed. Speed and accuracy bear an inverse relationship. It will be in the inverse relationship. High speed system to be less accurate has less amount of information as received. So the high speed, whenever it will be the slow, the comparison of slow speed and high speed you have taken, then high speed will be less accurate than the slow speed. Protection to strike a balance between the two incompatible requirements. That means the speed means to whatever the fault will be occur. So you have to isolate that part very quickly without the disturbance of without the damage of the other equipment. That means devices must function quickly to reduce the equipment damage. Devices must function quickly to reduce equipment damage and fault duration. So this is about the speed of the operation. Next goes to the what is. So whenever what is the reliability, then generally we know that what is the reliability for system operation, for any power system operation, we have high degree of reliability is required in order to protect the system from damage or abnormal voltages. We have to be cause the that means abnormal causes of faults need to reliable protection devices. So reliable. So we already tell that there is a circuit breaker and relays must be there. So whenever the system operates, high degree of reliability is required. In order to protect the total system, we have high degree of reliability system. That is the trustworthiness. Assure the system will perform correctly. So we have to check the total when it will be before it will be start of the any system. Then we have to check the total. That means the quality of the components. You have to check how the quality will be there. You have to check the quality of the system. And what is before we have to design the protective system. Then what are the if there is any cause must be there, any damages must you have to get, and maintenance every. So we have to suppose if there is we want to maintenance will be need that system. So simply we have to that is in the normal conditions also we have to operate that in the maintenance part. And then internal, and if there is external stresses will be, that means there is internal and the external any faults must be obtained for that. So you have to check the and manufacturers of protective equipment. So you have to protect that equipment. So for a manufacturer you have to total designing the protection must be manufactured. That if you take the one equipment, what about the manufacturer, what is the quality and what is the designing process, and it is used to the electricity board industry. So when you have to the reliable, if the system it operates, the high degree of reliability is required in order to protect the power system. That means assurance that system will be correct. That means devices must function consistently when fault condition occur, regardless of possibly being idea for months of years. Without its reliability, systems may cause costly damage. So reliability means it will be assurance the system will perform correctly. Next upon what is in this reliability of the system, there are main thing I tell that there is two aspects of system. So one is the dependability of the system. One is the dependability, and then will be the security. What is the dependability? So it is the trustworthiness. So assurance that system will perform correctly. The system will perform correctly. So whenever dependability is the certainty that whenever it will be operate in the correct manner, then only, that means there is the different zones must be there. So you have to protect operate whenever you have to operate in the correct manner, then only that will be called dependability is the ability of the protection system to operate when called upon to remove a fault elements from the power system. Dependability, it is the ability of the system to operate when called upon to remove remove a faulted elements from the power system. That means, so here the complete dependability is to perform correctly, and we have to relay. If suppose a relay is said to be dependable, if it trips only when it is expected to trip. So if suppose the relay must be there, if there without fault will be occur, then you have to trip that relay will be tripped. Then what happens? The total will be damaged. So whenever it will be required, then only it will be operate. That means then only it will be operate. It's nothing but the dependability. That means it will be performed correctly when it required, and it will be the whatever the relay will be taken, you have to be dependable only when it is expected, and will be operate in the correct manner. And this that means there are zones must be there. So dependability will be depend upon to protect the system to operate when upon to remove the faulted elements from the power system. Next slide will be the security. So what is the security? Security means one thing we know that secured. It is a secured. So secured means something is to ability of the protection system to restrain itself. It will be ability to restrain itself for operating during external parts. If there is an external part, you have to secure that system. So with how you have to say secure to protect the system to restrain itself from operating to an external fault. Choosing the appropriate balance between these that means to avoid unnecessary operation. So relay, whatever the relay will be placed, you have to be secured. If it does not trip, whenever if it will be wanted to trip, then only it will be trip. Otherwise it does not. So it will be in the secure position, and that means if any incorrect position the relay will be operated, then it will be open, will be damaged. So that means the circuit breaker will, whenever the relay will sense the signal, the circuit breaker closes. So when it will be the operator, when it will be operate, when it their fault will be occur, then only. So security means and to avoid the unnecessary operation. That means tripping of will be on the, if it will be the tripping of the fault conditions, then it will be in the incorrect manner. So the relay whatever is secured, if it does not trip, that means The protection, it is the ability to protect the system, to restrain itself from operating to an external fault. That means the appropriate, whatever the reliability and the dependability and the security must be there. It is a balanced between the security and dependability to design the protection system requires. So engineering to various cases of, so that means whenever you have to design, whenever the system must be in the reliable condition, then what we do, we have to balance the total system. That is about security. So here the dependability and security must be there. Here the dependability means to perform when it will be required. So whenever it will be required, then only it will be performed. So security means to avoid unnecessary operation. To avoid unnecessary operate will be avoided. So how you find out the percentage dependability means here the number of correct tips by number of desired tips, and security means number of correct tips by total number of tips. So this is that means it will be the both are in the balanced condition when you have to be taken the dependability and security. So dependability is the ability to protect the system, to operate when called upon the to remove the fault, and the whatever the selective is the protective system to retain itself for operating during an exercise. So these two conditions are put in the balanced manner. This is about the reliability. Next one is simplicity. Next one, simplicity. So what is simplicity? Simple. That means devices must minimize protection security and equipment. Minimum protection equipment. That means protection system should be kept as simple and it will be possible so that it can be maintained. So whenever we have to put it in the complicated form, then the total system, whatever suppose any damage will be occurred, the total will be cost of the equipment will be also more. So for that purpose, we have to the system should be, it will be maintain the system in the simple manner. So simple and straightforward. So straightforward so that it will be maintained in full. Simplicity, we all know that it is the closely relationship of the it is closely relationship of the reliability. Why? Because we already know that simplicity devices must minimize protection equipment, and it is simple the protection, the greater will be whenever whatever we have the good reliability of any system must be there. We have to, the system will be in the form of the simple, then you have to get the good reliability of the function. And increasing use of solid state and digital technology provide convenient possibility from possibility for increasing the systematic. That means this total simplicity is depend upon the in the whatever the system will be in the form of the simple, then the total part will be the reliability and the cost point of view less, and whatever it may be, we have taken in the easy part. That means whenever it will be the simple, we have to reliability will be more. So we have to put the system will be in the simple manner. And then economy. We all know that what is economy? Devices must provide maximum protection at minimum cost. We give that whatever the economy means, any system we take, it will be use the maximum protection, but minimum cost will be the maximum. That means protection costs are considered high when considerable alarm. That means if the cost will be more, then it will be, we have to, if suppose the number of transformers are placed, number of, if suppose when you take the whatever step up and step down, whatever transformer, if the cost point of it will be more, then the maximum it will be more economy is there. So what we do, it will be do the maximum protection, but we have to the minimum cost. So in the much higher cost of equipment, they are protected, and cost of outage is the improper protection. So here, what a protection system, that means the economy is the should not more than 5% of the total. It is a very important. The whatever the total cost must be there, it does not be this protection system should not be more than the 5% of the total cost. So here the protection economy means we have to the maximum protection at minimum cost, and it will be the cost and the considered will be high when considered alone. So whenever it will be we have taken the any system, we have to protect, we have to take that the how much of the cost will be there. So we have to do the complete protection but with minimum cost. So we all, so what are the essential qualities? There is a reliability and selectivity, speed, economy, and simplicity. So this reliability will be, there is a dependability versus simplicity. That means, so whenever we have to be taken the very devices, must when it will be the in the reliable portion, and it will be the economy portion, and what is the speed it will be taken, and how the devices will be selective. Whenever the devices will be selective, so there is, it will be select only that part, and there it will be isolate that part only. So it will does not touch the healthy part. So these are the essential qualities of. We are now telling that there is a fault obtained, from that fault only we have to protect. So we have next we have to do what about the faults. What about the faults? So any we have any abnormal conditions, that means generally what are the fault for whenever the fault will be occur abnormal condition, then what when it will be overloads, under voltages, over voltages, there is the network will be the unbalanced system, there is reversing of the power under frequency, when switches are instability, over temperature, these all will be required for the faults in the power system. Generally, the power system will be only, it will be classified as the faults will be open circuit fault and short circuit fault. So open circuit fault, when it will be the whatever it could, then it will be the some three-phase lines first be or YB, whatever it may be. So whenever there is the one line, there is it will be the open, then it will be called as the open circuit fault. So that means under the open circuit fault, there is one conductor will be open, or it will be open the two conductor, or it will be open the three, whatever it may be. It will be open one conductor open, two and three. Then it will be termed as the open circuited fault. So and then it will be called as short circuit faults. So open means whenever the voltage must be, it will be more, then it will be called as the open. Short means when the current must be more, that is open circuit fault, short circuit. So short circuit fault, again there is the symmetrical fault and symmetrical means it will be the balanced but the current will be more, then it is called symmetrical fault. Unsymmetrical faults must be the system does not balanced, that system is called as unsymmetrical faults. That means balanced condition means if you have to taken as three phases, each phase will be 120 degrees phase difference, and the magnitude of the voltage will be, suppose we have to taken as this is R phase and this is Y phase and this is B phase. These three phases where the magnitude must be same and the phase angle will be 120 degrees on each phase, then that system will be the balanced system. Otherwise, this magnitude and the phase angle will be different, then it will be called as the unbalanced system. That means when suppose whatever the input load must be there, it will go to the output, then you have taken, it will the system will be in the continuity process and system will be in the balanced system. But whenever it will be the load will be in the different, then the fault will be occurring, then the system will be unbalanced. But I am telling that symmetrical fault, symmetrical means same, that means balance. It is also called as balanced system, but the current will be more. So that fault is called as symmetrical fault. But unsymmetrical fault means the three, whatever the three phases must be there. It will be one phase, and it will be some 90 degrees, it will be some 12 degrees, or that whatever the phases must be not equal. Then that we tell that that is the unbalanced system. That is a balanced, and balanced means, remember, balance will be the same magnitude with 120 degrees phase difference, same phase difference, but unbalanced, it is the different system. So symmetrical faults are very dangerous faults. So here, whenever a three-phase short circuit fault must be there, and the three-phase ground fault, suppose that means here we have to take as three phases, that is R and Y and B. So and B must be there. So whenever the three must be in the short portion, that is three phase shorts. The three, that means the current will be in the more, so that the resistance point will be, the impedance will be in the less. Whenever, according to Ohm's law, we have taken some I is equal to V by R. I is equal to some V by R. So whenever resistance will be less, the current will be increased. So whenever the three lines must be short, then that is called as three-phase short circuit fault. And three-phase ground faults. In a three-phase ground fault means when three must be short and it will be ground, then it is called as three-phase ground fault. Three-phase ground fault. So why I am telling this symmetrical fault will be the balanced fault means, because here the whatever the balanced condition must be there, that because the three phases must be in the shorted, so the three are in the balanced condition. But whenever the fault will be occur, the short circuit fault will be occur, it will be the current will be more. That is due to the low resistance part or low impedance part. So the current will be more. So for that point to symmetrical fault is balanced, but it is a fault because here the current will be rises. So these are three-phase fault. Three-phase, one is a three-phase fault, and another one is three-phase ground fault. And next one is unsymmetrical fault. Unsymmetrical faults are single line to ground. So when you have to take in the three or Y, B phases must be there. So single line to ground fault, one line and it will be grounded, line to ground. Suppose that means line to ground means if any, it will be touches any tree, then the fault will be occur. So that will be line to, if suppose it will be touches the tree here, then it will be fault will be occur. That is single line to ground fault. Then it will be double line to ground fault, double line to ground fault. So double line, so it will be short two, and then the two lines will be shorted, and then it will be grounded. Then it will. So mainly due to the lightning strokes will be happen that when the two wires must be in the swinging positions or there, then it comes to the double line to ground fault. And then to line fault. Each line there is no touches, but whenever two lines must be touched, line to line fault, when it will be the short, then it is called as line to line fault. So here the basic we have to explain about that, the symmetrical fault and the unsymmetrical fault. Here the symmetrical faults are we have taken, it is a balanced fault, but the current will be increased, so that we have to take as it is a symmetrical fault. But unsymmetrical means it does not the balanced condition. So but the whatever the we have the faults will be occur, that here line to ground faults, a major, and line to line to these faults will be. But when you get the symmetrical faults will be obtained in the 5% or more, because when you get that much of the faults, it will be very dangerous faults. This is about so a fault whichever in failure in with the normal flow of current. Whenever the flow of current will be, that means any fault will be occurred. That means abnormal changes of the currents or voltage, whatever it will be there. The frequency of the power system is obtained, then it is called as the fault. So Generally, I have told that there is a open circuit fault and short. What are the faults obtained when we have to protect from that fault means if you have open circuit fault means so open circuit is nothing but if there is when it will be the open circuited then the total condition there is no break in the conductor. That means if three wires must be there, there is a one conductor, two conductors, and three must be there, three phases must be there. If you have to be open the one phase, it will be the open circuit faults. Like that. So here you have to show types of the open circuit. There is single phase open circuit. Here the two phase open circuit and here three phase open circuit. So you have to see here the one three phases must be there or VY and phases must be there. So here we have to open the one by PQ in the open condition. So that type of fault will be the open circuit. Here we have to take here the two lines must be in the form of the open circuit. So it is the two-phase open circuit. So when one conductor will be in the form of the open, then it calls. Here we have to say three phases will be in the open form. So it is called as three-way open circuit. So, short circuit, we all tell that there is a symmetrical faults and the unsymmetrical fault. I show you the diagram. So, these are the symmetrical faults. And telling that triple LG faults. Triple LG. Triple LG will be L line to line to line to ground fault. Line, line, line. So, A, B, C, R, Y, B, whatever the phases might be. The three phases will be touches to the ground. Then it will be called as line to line to line to ground fault. Then it will be here we have to understand the three phases must be in the balanced condition, but the fault will occur when the current will be more. So from that point of view, this symmetrical is the balanced faults. And here you have to take in that here the three faults must be there, but it does not count. So it is called L, 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 line to line to line fault. This is called as line to line to line fault. And then next one, this is the unsymmetrical. We already discussed about. I showing the diagrams. So single phase to earth fault. So single phase, there is three phases must be there, but one phase will be connected to the earth. Here the two phases will be there, but two are in the short form, but a phase to phase fault, but there is no ground. So this is LG fault. This is LL, line to line fault, and this is LLG because the line to line and ground fault. So unsymmetrical, it does not in the because you show here there is only one phase, there is no another two phases. Here you show there is two phases, there is no another phase. So here there is three phases, but whatever there is another phase must be. So it is called as unbalanced system. Unbalanced system. So unbalanced. So it is called as unsymmetrical. Symmetrical must be same, unsymmetrical must be different. Next, what are the main causes of the current? Main causes of the faults. So we know that there is overcurrent fault and leakage current, overload, unbalance, and reverse power supply. That means if suppose overcurrent must be, if current, whenever the overcurrent is to be obtained, whenever the condition must be in the short, then only the over condition must be obtained. When only the over condition must be obtained. That means whenever if suppose whenever the current, that means suppose the resistance will be when it will be the over, it will be the short, then automatically the current will be increases. Whenever the current increases, the resistance part it will be the low resistance part. So whenever the resistance part will be zero, it is then the total it will be current will be in the high current will be flowing. That means infinite current will be flowing. So that is the overcurrent fault. Next, leakage current. So if suppose there is a one transmission line when conducting wire must be there, so it will be ionized. That means due to the corona, that will be ionized. The amount of the current will be flowing from outside. So that form is called as leakage current. Leaking of the current. Next, overload. When it will be, suppose I am sending the some 11 kV or 220 kV, whatever it may be, I am sending. The output will be in the much more of the load must be taken. So much more load will be taken, then it will be called as overload. and then unbalanced system. If the three conditions, three systems, three phases must be in the unbalanced path, then it is called as unbalanced system. Then what is the reverse supply? If suppose reverse supply means, suppose we have taken one motor, here the supply voltage will be some 220 volts. This is back EMF in the motor, there is a back EMF will be. So whatever the current will be flowing some I. So suppose this is EB will be 150 volts or 220, that is 215 volts also. Then EB will be less than the 220 volts, the current will be flowing like this. Whenever the EB will be more, because here there is 220, suppose it will taken as 240 volts, then the current will be in the reverse direction, reverse power supply. That means whenever EB is greater than supply voltage, then automatically the current will be required. Whenever that back EMF is always less than the voltage. So causes of the faults will be, there is overcurrent. So overcurrent in an electrical, overcurrent means if there is any excess current is situated, when large, that means automatically when it will be, the current will be more, then the heating effect will be more, then it is more risk to fire or risk to damage the equipment. So whenever it will be, that means it is a low resistance, comes to the low resistance path, so the overcurrent will be upward. Next వచ్చి leakage current. Whenever there do current, some current will be goes to the outside, some leaking of the current, then it will be the cut between the ground. That means the flows when an unintentional electrical component. So whenever the current wire will must be there, it will be leak some of the current, then it is called as leakage current. Then overload, you have to put so many loads is there, the input will be one, but will be the output will be somewhat, then it is system will be over. The overload, when you draw more electricity than the circuit, then it is called as overload condition. Next one is unbalanced system. Unbalanced system means if the voltage magnitude, that means I already tell that you have to change. This is one phase and this is one phase. So this is a long phase, but here what are the phase difference? What about the magnitude? The three must be in the unequal portions. So this must be, it is called as the unbalanced system. And then reverse power supply, or the flow of power will be reverse direction. Reverse direction means I already said that one motor will be taken, the back EMF will be more to the supply voltage. When it will be the back of the current will be there, then it is called as reverse direction. So these are the protection system. I mean, what are the faults? That is open circuit faults and short circuit faults must be there. So we have to be, whatever the faults will be there, we have to see. Then how you protect that faults? How you protect that faults? That is the very important. So what we have the, what is the types of the protections? We have generally in the power system, we know that there is a generation, transmission there. For every system, every power system, in every element, there is a protective zone must be there. There is a protective zone. So we have to see that there is the generator, transform, bus bars, transmission, distribution line. If suppose we will connect the protective system to generator, it is generation protective system. We will connect the transformer, it is transformer protective. If you connected the bus bar, it is bus bar. Or if you connected the transmission line, it is a transmission line protective. So every power system must be connected in a separate protection system. Then only we have to be form of the good reliability. So generally, that means protective zone, it is a one part of the power system. So to protect a certain product, it is established in each power system equipment. Whenever the fault occurs of any protective zones, then only the circuit breakers within the zone will be opened and the element will be isolated without disturbing the remaining parts. That means there is a different zones in the protection zone. So it is various zones. Only the suitable protective zone scheme, whatever the suitable will be there, we have to put That only. That means main thing you have to take as the relays and the circuit. So basically there is the two protective zone. One is primary protective zone and second one is backup protective zone. So primary protective zone and primary means we have whenever it is not clear, the primary circuit breaker is not clear the fault, then it goes to the again the backup protection will be take care of that. If you see this figure, you have to understand. So suppose if this is the power station 1 and this is the power station 2, here there is the transmission line EEF, that is circuit breakers are there. If this is the primary protection and this is the second backup protection. So primary protection and the main purpose of the primary protection is the first. If suppose if this is the EF must be there. Suppose this is the primary. If if BD whenever the fault here some fault will be occur, whatever the fault will be occur here, then first they have to be sends the signals to the that BD relays will be and GI relays will be operate. So this relays will be operate. If suppose this relays does not operate, but it will be suppose this will be some 0.3 seconds. Whenever that time will be over, then only this backup protection will be operate and it will be circuit breaker will be closed. It sends the signals to the circuit breaker. You understand? This is the power systems network. Here the true protective, whenever the transmission line must be there, whenever the fault will be occur here, then the primary the primary protection will be occur. So the primary protection is the first protection which provides quick acting and selective clearing of the faults. If suppose this primary protection will be act, that means after the time will be open, it does not be open, then again the backup protection will be operated. Otherwise the total continuity of the supply will be damaged. So for that purpose only this protection system will be done. So yeah, this is BD and GI is first activate and then AH, AC and HJ will be next operate. This is the primary and so this is the what are the different zones of the protection. We already tell that there is a generation protection zone. So here generation protection zone and there is a transformer protection, transmission line protection. So every bus part system, every part will be there. We have to the separate protection zones must be there. So here when here we have taken the generation, there is some circuit breaker is there. There is you have to protect that whenever the fault will be occur, the circuit will be breaker will be open and then it will be protect the generation of the system. Suppose if the transformer will have the some problem, the circuit will be open and then you have so every zones means the primary and the secondary must be there, but we have to protect that system. When you have to protect the system, suppose every protective system will have each protective zones. So here when you observe that power systems contain, there are the many components, number of zones and unprotected zones overlapping each other. Here we observe your generating station here like this, but there is another overlapping zone for this generation station. So here it is one protective and it is another protective. Why you have to taken like this is, suppose I have taken suppose this is a generator and I have taken this is some transformer. If suppose generator has separate protection zone and transformer has a separate protection zone. So whenever the fault occurs in the generator, it will be there, and transformer will be protected. It will be. Suppose if it will be in the boundary of the system, I get the fault here. Then what happened? The generator will be decided. The fault will be occurred to the transformer. The protective zone will be acted as a transformer. transformer will be there, the generator will be active in the circuit breaker opens. So the total system will be failure. So from that point of view, whatever the generator must be there, then we have to overlap this transformer. So whenever this here it will be fault occur, whenever the generator circuit breaker will be not operate, then transformer will be operate. There is a, that means zones compulsory, it is overlapping of the each other, overlapping, because you have to protect any zone. When it will be in the separate point of view, it does not will be the protector. So we have to overlapping, then you have to decide a generator. If one breaker is not taken that fall, another will be acted and the continuity will be there. So that is called as protective zone. And one thing you have to suppose here there is some fault will be occur. Whenever the fault will be occur, this breaker, and these four breakers will be only active. Then only if suppose the fault will be occur, if suppose this breaker will be active, this breaker will be active, then the total damage will be disturbed. It will be disturb the total system. So only that particular zone will be taken, isolate the fault, and it will be whatever the fault will be rectified, and it will be the breaker will be closed. So the overlap, the main important point of view here is there is a primary and the secondary zones must be there. But the primary zone, if the fault does not accept, it will be not act, it will be not open, then what about it will be the some due to the some lag time. If suppose it will be 0.4 seconds up to 0.4 seconds, back protection will be in the stay form. After completion of the 0.4 second, then it will be the backup protection will be active. So that is a generator and transmission. And overlap each other means whenever it will be the overlapping of the each other means, so whenever without overlapping, then the total system must be damaged. So this is the same thing, overlapping zones. So when you are understanding this too, here the same thing. In the last slide, I will tell this is the generator or this is the transmitter. Whenever the fault will be occur here, whenever this circuit breaker will be not accept, here the another circuit will be taken, will be accept. So there are different protective devices must be there. There is for the protection of the total equipment, there is the circuit breakers and relays must be there. So it is what may be circuit breaker. What means it is the opens or closing of the circuits under the fault condition. That means it will be operate under the normal conditions and it will be the operated under abnormal conditions. So generally, whatever I have told that, yeah, there is a circuit breaker must be there. Generally, in the circuit breaker, there is the two coils must be there. One is the fixed coil, and another one is movable coil is there. It is fixed coil is connected to the supply, and movable will be connected load. If suppose if the rating of that any generator, whatever it may be, the ampere will be the 10 amps, whatever it may be, if exceeds that load, then the whatever this fixed moving coil is there, first it will be connected to, then it will be separated. This is fixed coil and this is moving coil, because this breaker will be open. First the circuit breaker is in the closed form. Whenever the fault will be occur, the breaker will be open. How the breaker will be open? How when the relay will be sends the signal to the circuit breaker, then only it will be open. So here you have to see in that here the two coils must be there. There is the fixed coil and one is the moving coil. So whenever it will be open, whenever there is the fault occur in there, then only it will be open. Whenever it will be open, then one thing we remember, there is the arc ionization will be obtained, because there is, whenever there is the open must be there, the voltage will be, the potential difference must be high, and it will be the air, whatever the air must be there, oil must be there, it will be the, whatever the electrons ions must be in the form of the ionization. So due to the ionization, there is the overheat will be obtained, that is over 5 will be obtained, and then the total system will be uh, damaged. So whatever the arc must be developed here, we have to reduce that arc to that means we have to reduce, we have extinguished that arc with some media. With some media means there is a in circuit breakers there is a, so many cool particles must be there. Suppose if here we take in the exception tags, like but whatever the elements you have, whatever the medium is you are taking, there is I circuit breaker, vacuum circuit breaker, SFC circuit breaker, whatever the breakers must be there, they have good dielectric strength, good thermal stability, and good chemical stability is there, then only this will be deionized. If suppose arc extinguishing is more, then what happens? Again the current will be flowing. What is our circuit breaker will be there? Whenever the fault conditions will be there, we have to open that. We have to open. The circuit breaker will be open. But what happens here? Whenever the open will be there, due to the arc ionization, there is a voltage will be there. Some amount of the current will be flowing. Why? Because due to the transient analysis, there is the inductor and a capacitor is be there. So the inductor will be the energy storing element. So due to the energy, what is the behavior of that inductor is, it opposes the sudden change of current. It opposes the sudden change of current. So for that purpose, here there is some current is flowing again. Whenever some current is flowing, what is the use of the circuit breaker? So for that point of view, we have to extinguish this arc. So how do we extinguish this arc? This extinguish will be arc in the form of the two ways. That is, we have to increase the high resistance, and we have to another method is low resistance part or current zero method. High resistance method and low resistance method or current zero method. High resistance method means, if suppose whenever we already know that R is equal to rho L by A. Whenever we have to decrease the area of cross section, then automatically, and you have to increase the resistance of the resistivity of the material. Length is increases and resistivity of the material will be increases. When it will be occur, area of the, whenever the resistance must be increased, what about the current? It will be decreases. It will be comes down. So you have to increase the resistive strength of the material. Then that means high resistance method is used for the where due to the decreasing of the cross-sectional area and increasing the resistive strength and increase the length of the material, then only we have to decrease we have to exist in the arc existence. Otherwise, that means then we have to cool the media using some gases. Another method is, but this high resistive method is used for the DC and AC only, but DC and both AC only. But whenever when you there is a low resistance method and current zero method is there, that current zero method is used for the only low resistance part, because in the here we are telling that DC, that means it does not comes to the zero position. Current zero position is there. Current must be comes to the zero position. So current, whenever the current must be in the zero position, it does not in the form of the in the DC, it does not possible. So we go to the AC. So because when you go to the AC, here there is the so waveform will be like this. The sinusoidal waveform will be there. So here we will show here the current will become at this point it will be zero. But in the when the form of the DC it does not capable. When you take the AC, it is the sinusoidal voltage will be there. So for that point of view here we have to. So at that time, whenever the current will be zero, at that time we have to remove that arc. Arc will be here. So it is a current zero method. It is also called current zero method. Current, why it is called current zero method? Current does not zero in the form of the DC. It will be zero in the form of the AC. At this point, it comes to the zero. At that point, we have to be extinguish the arc because there is a here there is some arc voltage must be there. Arc voltage is the voltage which obtained from this arc is arc voltage, and whenever we does not take it part to the at that time we have to rectify that arc. Otherwise, again it will becomes to the some voltage current must be there. That is called as restriking voltage. Restriking voltage means the voltage which develop the voltage which develop due to the transients. Due to the transients again, because I tell that it does not allow the sudden change of current. But due to the transients, it will be allowed. So that is called as restriking voltage. Another one is recovery voltage. Recovery means then it comes to the normal position. So, whatever the main disadvantages of this current zero method is, whenever it comes to zero, it is a very small time. For that time only you have to be extinguish the arc. Otherwise, again it comes to the restriking. So here, whatever the figure I will show. Generally, this will be the system voltage. Whatever the sinusoidal voltage will be there. Whenever the fault will be current, this is the fault current. Whenever we have to come to zero position is there. Whenever it does not come to here zero position, it does not come. Whenever this zero position is there, we have to extinguish here. Otherwise, what happens? There is a restriking voltage will be down. Again the voltage will be again the current will be more. So whenever the fault occurs, because why it is used at the AC means whenever the fault current will be obtained, this fault whenever this comes at the point of the zero position, at the very small time we have to stop that. We have to extinguish that arc. Otherwise, again the striking voltage will be developed. Then recovery, after that it comes to the recovery voltage. This is about the circuit breaker or extinguisher. This is current transformer, and these are the sum of the parts. That is the current transformer. And current transformer, why use the current transformer? Current transformer is whatever there is high voltage lines must be there. The high currents must be coming. There is 120 amps, 200 amps, 600. But whatever the meters we are there is 5 amps, 10 amps like meters are there. So what is the use of the current transformer? Is you have to be convert that high amount of the current into the normal point of view with the meter range point of view, and it will be used. Potential transformer means there is high voltage will be there. You have to take that high voltages and you have to convert in the form. There is very much 11 kV, 11,000 kV, 11 kV, 11,000 kilo kV. Like that is there. So we have to convert the power voltage is 300 volts, 600 volts, like that only. So you have to convert that high current, high voltage into the low voltage. That is the PT must be there. So this is about the current transformer. There is you have to take this is high tension line must be there, and from that there is a one coil will be core will be there. This high tension will be primary, and the whatever the ammeter will be taken is the secondary. Whatever the current will be coming here, then it will be magnetized and it will be converted into the form of the low, and it will be sent to the secondary circuit. So this is the potential transformer. And one thing, one important thing is that is a relay. Relay means generally we are telling that it is a sense signal to the circuit breaker. So how we have to sense the signal to the circuit breaker means generally the relay is like that. Here the NC and it is normally open coil and normally closed coil. So at the initial portion of the relay, it will be normal. Generally, when it will be normally open must be there. Normally, whenever the relay must be operated, it will be in the closed point of view. Whenever the high current, high voltage, whatever it may be obtained, then this will be comes to here. So normally open. So then it will be open and gives the signals to the, if whatever the open must be there, then it will be coming to, due to the attraction, electromagnetic induction, it comes to the closures and gives to the signals to the supply and gives to the sense to the DC circuit breaker. Then it goes in. That means whenever the over voltage, over current must be there, then only will be relay will be operate. When the relay will be operate means generally the circuit breaker will be in the closed position. Then we have to open. Generally the relay will be in the open form. Then it will becomes to the closed position and it goes to the signal to the circuit breaker and it will be the open. That is the relay purposes. So for this circuit you have to understand how. So this is the CT current transformer and this current transformer is connected to the here the relay secondary of the ammeter is connected to the relay. Here this tripping circuit will be there, plugger, this is also called as, and here the circuit breaker coil must be there. So whenever the high voltage will becomes to there, here the whatever it will be open, it comes to the closures and then it will goes to the supply here and this electromagnetism, this coil will be electromagnetization and generally this will be in the closed position, it will be comes to the open position. So generally main relay which we have to see that is in the transformer. We have to, so already all must be know that there is Buckholz relay must be there. So Buckholz relay purpose is it is in between the transformer oil and this conservator tank. In between there is a Buckholz relay. Is here in the Buckholz relay. There is the sensors must be, mercury coils must be there. There is a two coils must be there. So one coil will be in the upper portion and the other will be lower portion. When this relay will be operate, when the oil will be overheated and there is a gas will be obtained in the oil or there is any windings will be some damage, insulation failures will be occur, then Buckholz will be operate. But here to show that there is a two mercury coils must be there. Here the one mercury which is generally this will be in the like this position. Here two contacts will be open position like this. It will be there. Mercury will be like this. It will be open. It is horizontal place. Whenever there is if here what is the purpose of two will be there. Whenever the low failure must be there. Low failure, that is whenever the gas oil will be heating. So we have to release cock and we have to reinstall the oil. Whenever the small repair will be there, then what happened? This whatever the mercury is like this, it will be goes like this. Then it will be the whatever the liquid will become like it, and it will goes the alarm will be clock this the alarm. Then we have to repair. And then what is the use of the second mercury coil is this. Whenever the high repair, whenever the high fault will be occur, then automatically it will becomes like this portion and the whatever the circuit must be there, circuit breaker must be there, it will be off that position. And then these are the some advantages. So it will be minimize the fire damage, whatever it be, and whenever it will be failures must be occur, it will isolate that fault conditions and it will be boost the signal to the part and it will be protect the complete path. Any queries? Thank you everyone for be patient with me. Thank you everybody. Thank you my old batch students and whatever my parents, my sisters, and thank you Secretary sir for giving this opportunity for live presentation and for the supporting of the system admin permission, sure, whatever it may be. Thank you very much. So we have to use software used in the protection system, yes, because now there is a cyber security problem is there. So we have to with some due to this we have to hack that grid system and totally it will be damaged. For that we have to use the software also use presentation. Thank you so much all of you, but for the patience. There is protection not only there is primary secondary zones must be there. There is high voltage zones must be there, low voltage zones must be there, and then there is over current differential voltage zones must be there, over current zones must be there. There are different zones must be there. All of you. Good to see you, March 2009 batch students. Be with me our college. Thank you, madam. Thank you, sir. Thank you for giving this opportunity, sir. Thank you very much, sir.